We're going to talk a little bit about light with the focus being on mostly sunlight. And starting off where light comes from, on the atomic level, you have electrons that are orbiting the nucleus. And when an electron drops to a lower energy level, it loses energy, and that energy is emitted as a photon of light. So that's what we call the little bundles of light energy. And so on the outer layer of the sun, there's a whole bunch of this going on. And we have accelerating electrons in the outer layer that creates these electromagnetic waves, and these travel to the earth. They just go out from the sun and travel along, and eventually some of them will hit us. And the waves travel at the speed of light, 3 times 10 to the 8th meters per second, until they get to Earth's atmosphere. And they slow down the world's tiniest little bit, but we're still close enough to 3 times 10 to the 8th through air and vacuum, not much difference. And then when the electromagnetic waves reach Earth's atmosphere, a couple different things that it can do. Definitely interacts with the electric and magnetic fields. It'll either allow the certain frequencies to transmit through the atmosphere to the Earth's surface, or it will be absorbed. And there's a few different things that can happen with the transmission, and we'll talk a little bit about those. When it does hit the magnetic field, the charged electrons interact with the Earth's magnetic field, and that's what we see as aurora. So let's talk a little bit about light interacting with materials in general. And when light does hit anything different, so if it's traveling through air to water or water to glass, it's either going to transmit, it's going to go through it, or it's going to reflect back, or it's going to be absorbed. And it can do kind of a combination of any of those three things. So we'll start with reflection. Light waves bounce off surfaces, and there's a law of reflection that says it's going to bounce off the surface at the same angle that it hits it. And this is with respect to the normal perpendicular to the surface. And smooth surfaces create that nice, clean, specular reflection, so it looks almost exactly like the object that it's reflecting. Rough surfaces create what's called a diffuse reflection because it has so many different bumps and so many different angles to reflect off of. Those outgoing rays end up going in a whole bunch of different directions. When light goes through a material or transmits, it's going to refract. This happens because the light changes speed when it goes through a medium. Now, it's never going to get faster than the speed of light, but it will slow down if it's going through something optically more dense. And if it goes from something that is more dense to less dense, like glass to water, it can speed up. So optically thick materials will cause the light to slow down, and it'll bend it towards the normal line. And the normal line is an imaginary line that's perpendicular to the surface. So it's the one that's shown in red in that picture. If it's going from an optically thick material like glass to a thinner one, air, it speeds up and bends away from the normal with the surface. And here's something else that can happen, and this is actually related to refraction, but this is when you have white light going into a piece of glass or water or something else that's going to cause it to refract. And because white light is made up of all the different colors of visible light, each one of those different frequencies refracts differently. And the violet light, the purple, is going to bend a lot more than the red. So that's how you end up with the rainbow colors that come out of a prism. And so here's a little bit about rainbows. Kind of cool that, the light, the white light hits the raindrops, and it does all three of those things. It refracts, it reflects, and it disperses. It goes in, and then it reflects off the back of the raindrop, and then it's going to refract on its way in and refract on its way out. It's going to end up dispersing along with the white light spreading. A couple different other things that can happen with light. These are kind of unique. One of them is diffraction, and that is definitely something that waves do. When a wave gets to a small opening, it actually goes through and spreads. And if you think about how sound works, it's a little bit more obvious. So if I'm standing behind a little door or something and you're in a room, you can hear what's going on in the hallway because those sound waves spread out and can go not just in a straight line from the door. Light does the same thing. Light also interferes, and we talked a little bit about this with waves, and the idea is that the peaks and the troughs add and subtract from each other. It'll do the same thing with the mediums that it's going through. One of the ways that we see this is if you've seen the sheen from oil or soap bubbles, that's actually because the waves are reflecting off two different surfaces, one at the top of the film and one at the bottom of the film, and those two different waves interfere with each other on the way out, and they appear to us as different colors. And so the last little bit is called Rayleigh scattering, and it's just call it scattering. And it's the sunlight is scattered by the little tiny particles in the air, and the particles absorb the light and then re-emit the wave. So it's absorbing and re-emitting those photons at different frequencies, and it just goes out in all different directions. The frequencies that are purple or blue scatter the best. That's why we see the blue sky. Red and yellow don't scatter very much, so that's the sun is nice and yellow, and it's hitting us directly, and it's not scattering. And then all around where the blue sky is where it's scattering. And you'll notice that sunrises and sunsets are more brilliant and more colors when they have smoke in the air or dust storms go by, and it's because of that scattering. Kind of related to scattering, we have polarization, and it's not getting emitted and absorbed. It's actually going through a filter, and the filter causes only certain waves going certain directions to get through. So if you can imagine a picket fence, only things that fit through are the things that are parallel to the pickets. The things that are perpendicular get stuck and won't go through. And so it lets through a certain amount of waves, so it's going to cut back on how much light gets through. And polarized sunglasses eliminate the glare from the road because they eliminate the horizontally polarized light that comes off of the surfaces like waters and roads. And so the thing to think of is that depending on what's going on with the surface that the light is hitting or the medium that it's going through, it's going to reflect, refract, diffuse, diffract, interfere, or polarize, depending on what's going on with the medium the light is interacting with. And they all have different rules, and they all cause some interesting effects. Alrighty, bye-bye.